2.4 The Chain Rule, Part 1. The chain rule is one of the most important rules of differentiation. We need to use the chain rule every time when we have composition of two or more functions. So let's go ahead and do a little bit of a review on composite functions. So let's say I have fx equal 4x squared and g of x equal 3 minus x. Find f of g of x. This is composition of f composite g. Another notation of this will be f composite g of x. And order does matter. F composite g is not equal to g composite f in general. So what we do here is f is outer function and g is inner function. So you literally put g of x inside there. And as you see, g of x is 3 minus x. So you're going to substitute g of x for 3 minus x there. Now 3 minus x become your input for f function. So then now apply that as an input. F says whatever your input is, do 4 times input square. So f of input will be 4 times input square, and my input is 3 minus x. So this will be composite function of f composite g, or f of g of x. Now, if h of x equals square root of x to the 5th minus 4, find the f of x and g of x so that h of x is f of g of x as f as outer function and g as an inner function. Literally, what you see outside is outer function, and what you see inside is inner function. What do you see as an inside function, and what do you see as an outside of a function when you look at h of x? I can see that what's inside is x to the 5th minus 4. So you can call that inner function g of x. So then your g of x will be equal to inner function, which is x to the 5th minus 4. So call that an input. What outer function is really f of your input is just square root of input. I use the heart there so you can see that's just an input. And now you can use the x notation. So f of x is just square root of x. So you can check by put it back inside. So if we follow the rule, f of g of x, well, g of x is x to the 5th minus 4. And your f function is a square root of input, right? Whatever input is, put it inside of a square root. And if you do that, square root of input, and I get what I'm supposed to get here as h of x. So your g of x will be x to the 5th minus 4. Your f of x will be square root of x. Then your h of x will be f composite g. So now let's learn the chain rule. If y equal f of u is a differentiable function of u, and let's say u is g of x, and that is differentiable function of x, then y equal f of g of x is a differentiable function of x, and the derivative is expressed in 2 ways. Here's version 1. You could look at derivative y prime, which is equal to dy dx. Well, you first take the derivative of y respect to u, and you are really taking derivative of outer function respect to u times. Now you take the derivative of inside function respect to x. And intuitively, if you look at that, they are not numbers, but if you look at du, since these are rates, du, you can think that this will cancel and you are really getting dy dx. When you really take the derivatives, nothing get canceled really, but intuitively you could think y dy dx is dy du times du dx. Now version 2, to take the derivative of f of g of x, you are not going to replace g of x by u. You're gonna leave inner function the way it is and just gonna take the derivative of outer function with leaving the inner function inside without touching it. But now you multiply afterwards by derivative of inner function. But if you look at it, this is really the same thing as above, because if you were to replace g of x by u, then this will be f prime of u times u prime, and f prime of u is derivative of, since f is y, with respect to u, and u prime will be derivative of u respect to x. So it is really saying same thing, but version 1, when you are given a function, you're gonna substitute inner function by u, and in version 2, you're just gonna do it naturally the way it is without doing any substitution about the u, but mentally looking at inner function as inner function. So let's do example. Maybe at the beginning, version 1 might give you better idea of what we are doing. And then as you practice enough, version 2 will save you more time since you're not really replacing, so you're not doing back substitution afterwards. So here we go. So given y equal square root of x cubed plus 1, find the dy dx using version 1. So to use version 1, you need to decide what's y and what u is. And y will be a function of u. So you're gonna let what's inside, you're gonna call it u. So this become y equal square root of u. And then u is x cubed plus 1. So then first time, you're gonna find the derivative of y respect to u. So what will be derivative of y respect to u? Square root of u is u to the 1/2 power. So when you take the derivative of y respect to u, this is just 1/2 u to the negative 1/2 power, right? Now, what will be derivative of u respect to x? Well, if you want to take the derivative of this respect to x, it is, now we use power rule, 3x squared, and derivative of constant is 0, so I just get 3x squared. Then dy dx is dy du times du dx, which is equal to our dy du is right here, which is 1/2 u to the negative half times du dx is right here, which is 3x squared. So you multiply by 3x squared. But at the end then, you need to use substitution back what your u was. So now 1/2 u was right here. U is x cubed plus 1. That's where you need to put it back. So that will be x cubed plus 1 to the negative 1/2 power times 3x squared. So 3x squared is a numerator, 2 is denominator, and negative 1/2 power need to go to the denominator to become positive exponent, and it is square root of x cubed plus 1. Okay, let's do one more using version 1, and then after that I will start using version 2. Now let y equal sine of 8 over x and find the dy dx using version 1. And version 1 is you let y be function of u and let u be function of x. So inside the function you call it u. So this is what's inside, as you see, that will be your u. So y equals sine of u. Since the sine is outside, that will be sine of u. And your u is what we just called u, which is 8 over x. And we want to use this as a power, so we can use a power rule. So I'm going to change that to 8 times x to the negative 1 power. Let's find the derivative of y respect to u. So what will be derivative of y respect to u? What's the derivative of sine u, everyone? That will be cosine u, right? So that is cosine u. And what's the derivative of u respect to x? If you take the derivative of this, 8 stays there. Bring the negative 1 power to the front, and you lose 1 power, so it becomes negative second power. Now, dy dx will be dy du times du dx. So it will be cosine of u times negative 8 over x squared. Let's plug back what the u was. U was 8 over x. You put it back where u is, then you have cosine of 8 over x times negative 8 over x squared. Let's rewrite this. Final answer then dy dx is negative 8 over x squared cosine 8 over x. Now version 2. The derivative of f of g of x, this time it says, take the derivative of outer function and leaving the gx inside the way it is. And then multiply by g prime of x. Multiply by derivative of inner function afterwards. So let's see if we can do this without splitting y equal function of u and u equal function of x. So here's an example. Y equal quantity 7x to the 5th plus x to the power 4. Find the y prime. So clearly our inner function is what's inside of a parenthesis, right? So this is your inner function gx. So your outer function is this quantity to the power 4. So y prime, first we take the derivative of outer function, and outer function is something to the power 4. So derivative of the outer function is power 4 times something to the power 3, and that's something I do not touch. I need to copy exactly the same as original. And now you need to multiply that by derivative of inside the function. And inside, I have a 7x to the 5th plus x, because it is more than one term, and you need to put a parenthesis there. So that's gonna be, if you take the derivative of 7x to the 5th, it is 7 times 5x to the 4 plus derivative of x is 1. So this is what we need to multiply by. So that will be 4, 7x to the 5th plus x to the power 3 times 35x to the 4 plus 1. And that's how you would do the version 2 of chain rule. I like this because I don't have to split it, and it is quick, so it saves a lot of time. Let's do a few more. So let's say I want to take the derivative of y equal secant of 7x cubed. So again, you can see inner function is 7x to the 3rd power. So your outer function is secant x. Derivative of outer function. Secant x is a secant x, tangent x. So that's gonna be secant, don't change, so it's exactly what I have, tangent of what I have. Now times derivative of inner function, and derivative of inner function is 21x squared. So my y prime's gonna be, typically when you have a polynomial multiplied by any trig functions, then it is better to put this polynomial in the front so that it doesn't confuse about your input for your trig functions. So let's write the answer as 21x squared secant 7x cubed tangent 7x cubed. That is the answer. Okay, do one more. So let's say I have f of x equal negative 3 over quantity 13x plus 2 to the third power. It will be easier if we multiply this as exponent, yeah? So we can use power rule. Let's change this to a power. So negative 3 over quantity 13x plus 2 to the third power is negative 3 times quantity 13x plus 2 to the negative 3 power. So then clearly my inner function is 13x plus 2 and my outer function is negative 3 times something to the power negative 3. To take the derivative of outer function, leave the negative 3 in the front, bring the negative 3 power down to the front, and I have my what's inside to the lose 1 power. I get power negative 4 times, now take the derivative of inside the function, and because my inside function is 13x plus 2, when you take the derivative of that, I just get 13. So my f prime of x is equal to negative 3 times negative 3 times positive 13 is 117, and quantity 13x plus 2 to the negative power 4 needs to go to the denominator, and it will become 13x plus 2 to the positive 4th power, and that will be the answer of this problem. Alright, let's do another one. So f of x equal square root of 5x to the 4th plus 7x. So again, this one too, it will be easier if we change it to a power. So let's make it to quantity 5x to the power 4 plus 7x to the 1/2 power. So then it's clear that this is inner function, correct? So we just first take the derivative of outer function, and your outer function will be something to the 1/2 power. So take the derivative of outer function, then you get 1/2 something to the, you lose 1 power, you get negative 1/2 power. And what was sitting inside, we don't do anything to it first. And then we just multiply by now derivative of inside the function. And derivative of inside the function is derivative of 5x to the power 4 is 20x to the third power plus derivative of 7x is 7. So now your answer, my numerator is this, which is 20x to the third plus 7. 2 is in the denominator, and because this is a negative exponent, negative 1/2 power factor needs to go to the denominator to turn into a positive exponent. And when 1/2 power goes to the denominator, I'm gonna change back to square root notation. So I have a square root of 5x to the 4th power plus 7x. So here is our f prime of x. In part 2, you are going to see some more problems that you have to use product rule with the chain rule, quotient rule with the chain rule, and you need to use chain rule twice or 3 times when a function is created by compositing 3 or more functions. So we're gonna see those examples in part 2. So have a break, and I will see you again in part 2.